Hello guys, so we are now going to go to Matplotlib. We've finished the 10 minutes to Panda series recently, so you can go check that out as well. So in this new series for Matplotlib, I'm again going to do the very same thing. I have some brief knowledge for Matplotlib, but now I'm going to dive into Matplotlib documentation in hopes to learn more. So first of all, I'll simply open the Matplotlib page and yeah, go here and go look for the tutorials page, the introductory tutorials page. You can find it just by clicking on tutorials and getting to this introductory section. Then you can just open. I'll start in the simple order, so I'll start with the usage guide. So yeah, first of all we need to import these two things. Import matplotlib as plt and numpy smp. Done. Now let's read stuff. A simple example, Matplotlib graphs your data on figures, that is windows, Jupyter widgets, etc., each of which can contain one or more axes, that is an area where points can be specified in terms of xy coordinates, yeah, or theta are in a polar plot, okay, or xyz in a 3D plot, okay. The most simple way of creating a figure with an axis is using pyplot.subplots. We can then use axis.plot to draw some data on the axis. Okay, so first of all, what does this do? Create a figure containing a single axis. So let's just try to run this first. Okay, it just creates the sample space and then we can plot these values. Okay, so I need to run these two together, I guess. First of all, I'll paste this and then do this. Yeah, so this creates the sample space, I reckon, this 2D space, and this then plots the data. So I guess this is a 1-1 relation, so 1 goes with 1, 2 with 4, so at 2 we have 4, at 3 we have 2, and at 4 we have 3. So we did not provide it all the data for all the intermediate values, so it's just connecting them via lines. Okay, so many other plotting libraries or languages do not require you to explicitly create an axis. For example, in MATLAB you can just do this and get the desired graph. In fact, you can do the same in Matplotlib. For each axis graphing method, there is a corresponding function in the matplotlib.pyplot module that performs that plot on the current axis, creating the axis and its parent figure if they don't exist yet. So the previous message example can be written much more shortly as this. Okay, so basically they're saying this that we do not need to predefine all this stuff. We can just use this plt.plot function. So you can just do this stuff without defining the axis. So we are getting the same result but with less lines of code. Okay, so now let's look at parts of figure. Let's have a deeper look at the components of a matplotlib figure. Should I zoom out a bit so that we can have a look at the entire figure at once? So parts of figure, yeah. So this is the figure, this is the legend, the title, the line plot. These are the grids and the markers for scatter plot. This is another line for a line plot. These are known as spines, okay, the x-axis label, the y-axis label, the figure itself, the major tick labels, and minor tick labels. So the major ones are these like 1 2, which have a longer line, while the minor ones are the subdivisions. We have a minor tick and a major tick and all that stuff. Pretty standard stuff, I'd say. So now let's look at the figure, the whole figure. The figure keeps track of the all the child axes, a smattering of special artists, title, figure, legends, etc., and a canvas. Don't worry too much about the canvas, it is crucial as it is the object that actually does the drawing to get you your plot. But as a user, it is more or less invisible to you. A figure can contain any number of axes but will typically have at least one. Okay. The easiest way to create a figure is with pyplot. So this does create an empty figure with no axis. This does a figure with a single axis, and this creates a 2 by 2 grid of axes. So let's just run them one by one. So this just created a figure with no axis. We tried this one before, if you remember, where there was just this, and then we also created this one. I missed the bracket. Here you have. Okay, so we this is not these are subplots. So four, 2 by 2, so 2 per row and 2 per column. Okay, I'll just pause here for a second. Yeah, so I'm back again, and now let's look at yeah, it's convenient to create the axis together with the figure, but you can also add axis later on, allowing for more complex axis layouts. Okay, now let's have a look at axis. This is what you think of as a plot. It is a region of the image with the data space. A given figure can contain many axes, but a given axis object can only be in one figure. Okay, the axes contain two or three in the case of 3D axis objects. Be aware of the difference between access and axis, which take care of the data limits. The data limits can also be controlled by axis.axis.set underscore xlim and these things. Each axis has a title. We can do this via set title, a x label and a y label. The axis class and its member functions are the primary entry points to be working with the OO interface. What exactly is this? I'm not sure. So let's just Google it up. Object oriented, I reckon. Yeah, it's object oriented. So now let's have a look at axis. These are the number line like objects. They take care of setting the graph limits and generating the ticks and the tick labels and stuff. The location of the ticks is determined by the locator objects and the tick label settings are formatted by the formatter. Okay, the combination of the correct locator and formatter gives very fine control over tick locations and labels. Okay, so I guess all this stuff is the axis, while these the interior parts are the axis with the eye. So the axis are what create all these markings and labels, while the axis is the entire region. Now artist. Artist. Basically everything you can see on the figure is an artist, even the figure, axis and axis objects. This includes text objects, line 2D objects, collections objects, patch objects. You get the idea, yeah. When the figure is rendered, all the artists are drawn to the canvas. Most artists are tied to the axis. Such an artist cannot be shared by multiple axes or move from one to another. Okay, now let's look at types of input to plotting functions. All of the plotting functions except numpy array or numpy.ma.mass array as input. Expect, acha, they expect numpy array or this as input. Classes that are array-like such as pandas, data objects, and numpy matrix may or may not work as intended. It is best to convert these to numpy array objects prior to plotting. Okay. For example, to convert a pandas data frame, you can just create the data frame and then use a dot underscore as array and you get a dot values. Okay, so let's just do this. Do I need to import pandas first? Yeah, I haven't imported pandas yet. So let's just import pandas right here. Done. And now this should work. So we have a as a pandas data frame and now we can convert a to an array a dot values. Okay, and to convert a numpy matrix you can do this. So let's just copy both of these lines together. First of all, you create a numpy matrix and bs array is np.asArrayB. So basically bs array is the yeah, new name and you have converted an np matrix to an array. So we can print out a as array, I think. Yep, and we can do the same with b as array as well. Yep. So now, can we plot these using the functions which we had earlier? Does plt.plot take in these directly? I'm not sure. I haven't really done any of this stuff. Yeah, so it took all of them as different data sets. So this was one, this was one, this was one, and this was one, and hence we got one, two, three, four, five. Why do we get five? Okay, so then this was like this. So this became one data set, this became one data set, this became one data set. You get the idea? Because we can also see it has four sort of junctions. The starting, this tip, and this tip. So four data values for each line. Okay. Now let's look at the object-oriented interface and the PyPlot interface. As noted above, there are essentially two ways to use Matplotlib. Explicitly create figures and axes and call methods on them, the object-oriented style. Yeah. Rely on PyPlot to automatically create and manage the figures and axes and use PyPlot functions for plotting. Okay. So one can do OO style like this. np.linspace. Okay. So you create this, print out x. So what does this basically does is it creates takes the starting value to be 0, the ending value to be 2, and creates 100 partitions between them. So 1, 2, 3, 4. Yep. So you get the idea. These are equally spaced numbers between 0 and 2. So you can yeah, note that even in the OO style we use pyplot.figure to create the figure. Okay. So let's just copy all of this at once and now look at it. Figure comma axis is equal to plot plt dot subplots. Okay, axis dot plot x comma x label linear. Okay, 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 okay. Yep. So what did was first of all you created the subplots. So like here you created this subplot stuff. Then I'm not sure why they are not in different boxes or same boxes. I guess we'll have to look at that when we get to the subplot part. Then we use axis.plot. We give x and x. So we gave the input to print a graph for x versus x and label it as linear. So this blue graph is now linear. Now we plotted the x and x square, and that is our um, this graph, which is the orange graph, which is the quadratic, and the cubic one, which increases the most sharply, is this. You have also set the x label to be x label. You can change this to maybe say you prefer x axis. You now have x axis here. You can change this to y axis. You now have y axis here. So what this is doing is you can also do, say you want to plot x square versus x. It should work. Yep. So now what happened was this is equivalent to plotting x versus root x. So I'll just undo the changes I just did. Oh, I made a blunder. X and x square. Yep. So you get the idea now. I'll just revert everything back to the same graphs. You can also change the title. It's right now a simple plot and axis.legend. If I remove this, let me just comment it out first. Yeah, so the legend vanished and now the legend is back. Okay, or pyplot style. We can do the same in pyplot. So right now we were using axis.plot, axis.plot, axis.setLabel. Now we are using the pyplot commands. Let's just compare them. So we did the same linspace stuff. Now we are using plt.plot here. plt.plot axis.set underscore x label. Oh, axis.set underscore x label. This seems much more simpler. Set title in, but it isn't much of a difference I can see right now. So maybe in the further lectures we'll see major differences which may be caused because of this. Now let's look at, actually there is a third approach for the case where you are embedding Matplotlib in a GUI application. GUI is basically graphical user interface. I'll be back in a second, one second. I'm back, guys. So there seem to be an unusually high number of people coming up today. So yeah, I'll just restart from here. Actually, there is a third approach for the case where you're embedding in a GUI which completely draws PyPlot. Even for figure creation, we won't discuss it here. See the corresponding section for more info. Okay, so in this part, okay, so you don't even need to use PyPlot. Okay, that's cool. Matplotlib's documentation examples use both the O and PyPlot approaches, which are equally powerful, and you should feel free to use either. However, it is preferable to stick at one instead of mixing them. In general, we suggest to restrict PyPlot to interactive plotting, example in a Jupyter notebook, and to prefer OO style for non-interactive plotting in functions and scripts that are intended to be reused as part of a larger project. Okay. Note: in older examples, you may find examples that instead use the so-called PyLab interface via the PyLab import star. The star imports everything from both the PyPlot and from NumPy, so that one could do this and this for an even more MATLAB-like style. This approach is strongly discouraged nowadays and depreciated. It is only mentioned here because you may still encounter it in the wild. Okay, point to be noted. Typically, one finds oneself making the same plots over and over, but with different data sets, which leads to needing to write specialized functions to do the plotting. The recommended function signature is something like this. So define the function, access data, and the dictionary. Okay, a helper function to make a graph. Okay, the parameters ax, which are the axis, data 1 the array, data 2 the y array. Okay, param dict, param is probably parameter dict, dictionary of keyword arguments to pass to axis plot, returns out list of artists added out, and this return out. So out is probably output. They created the plot and then they returned it, which you would then use as, okay, so data 1, data 2, data 3, data 4 they created, then they did this subplots for one by one, and then they used myplotter, which is the function we defined here. They gave the axis data 1 and data 2 and the marker to be x. So okay, you the marker is this, the symbol which is being drawn here, and okay, so this should work just like this, I reckon, or does it not? So this happened, and then you can just do this and get the same kind of graph. So let's change the marker. Say our marker is this. Okay, so markers also are probably predefined. So if we set it to be plus, you can see there are pluses here. So let's just change it back to x, and we are getting this plot. Okay, now, or if you wanted to have two subplots, you can do my plotter plt.subplot 1 comma 2. So 1 comma 2 is giving us just one row with two columns. Then you can plot two of them. So you can do something like this. You get two plots. Good enough. For these simple examples, this style seems like overkill. However, once the graph gets slightly more complex, it pays off. Yeah, that's true. So for maybe if you're plotting hundreds of graphs which are much more complex, writing down a function where you can just do this stuff without like uh, predefining many things which you might be doing, like redefining many things which you might need, is quite helpful. This is the main reason we use functions as well, so we do not need to redefine stuff for every task. uh, Now let's have a look at backends. What is a backend? A lot of documentation on the website and in the mailing list refer to the backend, and many new users are confused by this term. Matplotlib targets many different use cases and output formats. Okay, some people use Matplotlib interactively from the Python shell and have plotting windows pop up when they type commands. Okay, some people run Jupyter notebooks like I am doing and draw inline plots for quick data analysis. Other embed Matplotlib into graphical user interface like WX Python and PyGTK to build rich applications. Okay, some people use Matplotlib in batch scripts to generate PostScript images from numerical simulations, and still others run web application servers to dynamically serve up graphs. Okay, to support all of these uses, Matplotlib can target different outputs, and each of these capabilities is called a backend. Okay, the front end is the user facing, that is the plotting code, whereas the backend does all the hard work behind the scenes to make the figure. There are two types of backends: user interface backend for using PyGTK, WX, Python, Tinker, Qt4, or Mac OS X, also referred to as interactive backends, and hard copy backends to make image files PNG, SVG, PDF, PS, also referred to as non-interactive backends. Okay, understood this part. Now let's look at selecting a backend. There are three ways to configure your backend. The RC params backend default AGG parameter in your matplotlib file. The MPL backend environment variable, the function matplotlib.use. Okay, a more detailed description is given below. If multiple of these configurations are present, the last one from the list takes precedence. Example, calling matplotlib.use will override the setting in your matplotlib. If no backend is explicitly set, Matplotlib automatically detects a usable backend on what is available on your system and on whether a GUI event loop is already running. On Linux, if the environment variable displays unset, the event loop is identified as headless, which causes a fallback to non-interactive backend. Okay, here is a detailed description of the configuration methods. Setting RC branch backend in your matplotlib RC file. You can do this. You, so I'm not going to read all these things. You can just read them on your own. So you can do this as well. And now the built-in backends. By default, Matplotlib should automatically select a default backend which allows both interactive work and plotting from scripts with output to the screen and or to files. So at least initially you do not need to worry about the backend. And yeah, standard stuff. If however you want to write GUI or a web application server or need a better understanding of what is going on, read on. So right now I don't think we need to focus on this stuff too much, and this interactive mode, etc. I guess we'll have a look at these later when we probably will go more in depth into the documentation. Even at this level, I'm also not familiar with half of these terms, so I don't think it's a good idea even to waste time reading these things. Let's just finish this by reading the performance part. Whether exploring data in interactive mode or programmatically saving lots of plots, rendering performance can be a painful bottleneck in your pipeline. Okay, there are a couple of methods to reduce rendering time at the slight change in your plot's appearance. The methods available to reduce rendering time depend on the plot that is being created. Okay, understandable. So basically, when you create a plot, sometimes your the plot might be so complex that your computer takes a lot of time to process it. So you might not want to you might want to lessen the quality a bit and compensate for the loss of time. And basically, I mean that you might want to lessen the quality so that you can get the results a bit faster. For plots that have line segments, rendering performance can be controlled by OK and these two values, which can be defined example in the matplotlib RC file. OK, this is a boolean indicating whether or not line segments are simplified at all. This controls how much line segments are simplified. Higher thresholds results in quicker rendering. Okay, the following script will first display the data without any simplification. Try interacting with both of them. Okay, I'll just copy the entire code. This button does the same, I reckon. Just noticed it. Hmm. I don't see very much of a difference, but there must be some. Let's try paying heat. I do see finer detail on the first one a bit, but that I don't know which one is technically finer from the perspective of these values. The higher thresholds result in quicker rendering, so this one must be rendering faster. So this one must be simpler. Uh, have this one must have less details. So yeah, I'll leave it up to you to zoom in and check for fine details. Matplotlib currently defaults to a conservative simplification threshold of 1 by 9. If you want to change your default setting to use a different value, you can change your this file. Alternatively, you can create a new style for interactive plotting. Okay, the simplification works by iteratively merging line segments into a single vector until the next line segment's perpendicular distance to a vector is greater than the path.simplified threshold parameter. Okay. So basically what it will do is, say if you have two lines very close, it will merge them unless the perpendicular distance between them is greater than this. If it's greater than this, then you will see spaces between them. Okay, so now let's look at marker simplification. Markers can also be simplified, albeit less robustly than line segments. Marker simplification is only available to line 2D objects through the mark every property where line 2D construction parameters are passed, such as matplotlib.pyplot.plot and this. Okay, splitting lines into smaller chunks. If you're using the ag backend, then you can make use of this. This allows you to specify a chunk size, and any lines that are greater than that many vertices will be split into multiple lines, each of which have no more than this many vertices. Okay, unless this is 0, in which case there will be no chunking. Okay, for some kind of data, chunking the line up into reasonable size can greatly decrease rendering time. The following script will first display the data without any chunk size restriction and then display with the chunk size of 10,000. The difference can best be seen when the figures are large. Try maximizing the GUI and interacting with them. Okay, I reckon we might not see any difference once again. Yeah, can we zoom in? I don't know how we zoom in. Hmm. When you look up here, this seems at least a little bit more detailed than this. This is the only comment I can make. I don't know how we can reasonably see changes in a Jupyter notebook, but yeah, that's at most what I could see. Now let's have a look at legends. Legends. The default legend behavior for access attempts to find a location that covers the fewest data points. Okay, lock is equal to best. We saw this in pandas as well. This can be a very expensive computation if there are lots of data points. In this case, you may want to provide a specific location. So basically, it automatically chooses the best possible position for the legend, but maybe in some cases, it might have to do additional computation to find the best place. So in those cases, even if your program is already taking too much computational power, this can add on to it. So legends, we've done legends using the fast style. The fast style can automatically set simplification and chunking parameters to reasonable settings to speed up plotting large amounts of data. It can be used by simply running this. Okay, let's just do this. It is very lightweight, so it plays nicely with other styles. Just make sure the fast style is applied last so that other styles do not override this. Okay, so basically you are now using this style. So if I plot this, uh, let's just copy stuff from here till here. This stuff, there should be a change, I guess, but I won't be too certain because many a times it isn't really changing anything on the front end. um what did it really change? The background is dark. I don't know what is ggplot. Let's just look it up. So it automatically chose some settings. Ggplot in matplotlib. ggplot, which adjusts the style to emulate ggplot, a popular plotting package for R. Okay, okay, I get it now. So basically, this first section just covered the basic things as it was a usage guide. So these things might not be very important, especially this built-in backend stuff at first. So I didn't go much in depth in it. And now I'll probably start with PyPlot tutorials in the next video. So thank you guys for watching, and once again I'll mention this, I'm reading the documentation for the very first time myself, and thank you guys for this incredible journey so far, and maybe we can have much more fun in the near future. Thank you.